Assalamualaikum warahmatullahi taala wabarakatuh. First of all, I would like to thanks for giving me a chance to present my knowledge gained during my internship program at company STMicroelectronics Muar at Muar, Johor. This is my agenda for my presentation today, and I will explain in more detail at the next slide. So we will go to the first agenda, which is my course background. My name is Muhammad Ashraful Aiman bin Abdul Rahman. I study major in Bachelor of Electrical Engineering Technology Industrial Power with honor at Faculty of Electrical and Electronic Engineering Technology UTM. My training period was from 16 March 2021 to 27 August 2021. I assigned at Department Central Engineering in the team NPI Lead Frame team, which is supervised by Mrs. Nabiha binti Muhammad Noor, and my supervisor from faculty is Mr. Azhar bin Ahmad. Okay, we will go to the next slide, which is this is the manufacturing flow at STMicroelectronics Muar, and as you can see this picture, this is the basic process flow. So we have front of line and we have end of line, which is at front of line we have a wafer saw pre-assembly, and then we have die attach process, and we have wire bond process. While at the end of line process, we have molding, we have propping, and lastly we have testing and finishing. So basically, I directly involved in the earliest process before front of line, which is nib process and lead locking tab process. What is nib and lead locking tab process? So I will explain in the more detail at the next slide. NIP stand for non-adhesive etching promoter, which is we will plate silver on the back of lead frame to make sure the NIP lead frame meet the quality standard before it going to the next process. So in this NIP process, my role is to assist plating engineer to make sure all of the IPC have been performed after we plate silver on the lead frame. So this is the process flow for in-process control for NIP. In sequence, we have visual inspection, and then we have copper and Ag XRF thickness measurement, and then we have EBO test, and then we have sequential electrochemical reduction analysis, which is SERA, and then we have hot plate test, and lastly we have color meter test. So as you can see, all of these 6 in process control have 2 type tests, which is non-destructive test and destructive test. So in this in process control, we required total of 3 strip copper thickness plus 4 strip nib plated for run all of this IPC control. So I will go through to the IPC process that I actively involved. So for the first one is the thickness measurement, which is the objective of this measurement is to measure the thickness of copper or silver plate layer on the lead frame. This measurement will equate fixture scope SRF machine as the equipment, and then this process required 30 data measurement, which is 2 or 3 lead frames, and the measurement location is at the lead tip area, which is the critical area on the lead frame, and the spec required is for copper is 1 micron until 2 micron, while Ag, which is silver, at 0.1 micron to 0.3 micron. For the next slide is the sequential electrochemical reduction analysis, which is SERA. So the objective of this process is to detect the presence of silver oxide layer on the lead-plated lead frame. The equipment we use for this process is the SERA QC 100, and this process required 3 measurement points that must be taken, which is I show you on the lead frame. So, and then the measure location is on the die pad with the spec. We must have VF. We must have VF at below than negative 1.2 volt. So, as you can see the picture, there are the SERA QC machine and the result of the graph of the result. Next process is the hot plate test, which is on the objective to observe the discoloration on lead frame when exposed under high temperature simulate the same condition at wire bond process. The machine we equip in this process is Gold Flow GF XL, which required one strip for before hot test sample and one strip for hot plate test sample. The measurement location is on the wall strip. With the spec, we will see after the hot plate test, we will see uniform brownish color tone when we put the lead frame on 230 degrees Celsius temperature. So the next IPC process is the color meter measurement, which is in objective to measure the frame brightness after neat plated frame and to establish process control after neat process. The equipment we use is YS3060 spectrophotometer, which required 5 measurement point, and the location measure is the die pad location. So as you can see in the graph, this is the example for the data we collect after before hot plate test sample and after hot plate test sample. We will use S bar chart and R bar chart, which is S bar chart is the average of all 5 measurement point on the one lead frame, while R chart is the maximum minus minimum point maximum minus minimum value on the 5 measurement point and in the one lead frame. So this is the data that we have collect. Other than neat process, I also directly involved and actively involved on lead locking tab process. Lead locking tab process is the process after neat, which is we will apply lead locking tab on the lead frame on inner leads to avoid lead misplacement that might occur on fine pitch lead frame during molding or during material handling. So this process is applicable for for lead frames that have more than 100 leads on the lead frame, which is we will tap on the lead frame, and we have two package involved, which is super hidden package and then super hidden package. This is the picture of the lead locking tab machine. Okay, this is the lead locking tab process tab, which is at the first we have loader, which is the lead frame, which is the vacuum picker will pick the lead frame at the lead frame box and place at the conveyor, and then it will go to the X direction tapping, and then it will go to the X direction tapping, and after that it will go to the visual inspection to check if the lead locking have any issue, and at the end on the unloader the vacuum picker will pick uh, the lead frame and place at the lead frame box. At the end of the result we have two result, which is good result, and another one is the not good result, which is the not good result is mean uh, the lead locking tab might have some issue like any foreign material attached on it. Okay. In this slide, I think this is the most contribution that I give to support my engineer, which is to make a conversion for lead locking tab machine. So the objective for this conversion is to convert the machine to run super high dense or super high dense package, which is both of these package have a different size lead frame. So on the earliest month during my internship program, I follow the vendor for this machine, which is I learned from them how to convert the lead locking tab machine. So as the result, I only have I only required 2 days working hours to completely finish this lead locking tab machine conversion. So compared to before this, if my engineer want to do the conversion, he will need to call the vendor from Selangor and wait for the vendor to convert the machine. So in this lead locking tab machine conversion, we will have several part to convert, which is the lead frame case sensor holder, and then at the loader and unloader, at the loader and unloader we will have to change the sensor holder, and then the interleaf case, and also the frame picker we will adjust the vacuum picker. Next part involved for conversion is the tap feeder sensor connection, which is we will have to convert the sensor connection from super high dense to the super high dense connection, or vice versa. So the connection must be done by following the 3-row and 4-row uh, connection diagram. So because of my background is from electrical engineering, so this is the part that I think I was really enjoy. So we will go to the next slide, which is for the next part involved is the unwinder and rewinder base, and also the motor connection. So as your information, for unwinder and rewinder base conversion, we will need or two or three people to lift this unwinder and rewinder base, because it is the heavy material. So we will need to take out the unwinder and rewinder base, take out from the machine, and then change it to the super high dense unwinder and rewinder base, and re-enter the base to the machine. So as you can see from the picture before, which is from super high dense, this is the mess that I have need to do. I need to connect all of the motor connection and the sensor connection, and it takes so much time to connect all of the motor and turn to like this. That's it for the mission conversion. So in this slide is the tools cleaning, which is we need to clean the die insert, slipper insert, and the puncher. The objective of this tool cleaning is to clean the insert, the die insert, and the stripper wall from accumulate glue residue. So the frequency for this clean tools is minimum once per week, which is the duration is half day, depends of amount of the residue. So this tools cleaning will require if there are some issue on the lid locking tab. So this is the process of the tools cleaning, which is we need to down the tools, and then we need to dismantle the tools, and then we need to dismantle the component, and we will do the die insert cleaning. So this is will prevent the foreign material stick on the lid locking tab. So I have support on nib and lid locking tab process. I also have a support on data collecting, which is for the first one is push test measurement, which is the push test measurement occur after the lid locking tab process. The objective of this measurement is to measure the strength, the strength lid locking tab hold the lid tip. So the equipment we use for this measurement is the Knudsen Dash 4000 plus, which required 4 side times 12 unit data measurement must be taken. The spec for this measurement minimum is 10 gram. So other than that, it will be okay. So this is the example, the picture example for the push test measurement. And the next is the tap length measurement. So the tap length measurement is to measure the length of the lid locking tab designed for option B. So actually we usually use the lid locking tab designed for option A, but but at the times we need to change the lid locking tab for the option B. So I assign to take the length measurement to make sure the locking tab have the have the same spec on this locking tab for option B. So the equipment that I use for do this measurement is the smart scope machine. This is the example for the smart scope machine. And next is the cyber scan measurement. So for the objective of this measurement is to measure the flatness of the die pad after have an epoxy bleeding issue. So for your information, I have access on UM46 project and UR4649 project. So the spec for the flatness to measure the flatness is must be less than 6 micron to be considered it will be the okay. So this is the cyber scan machine, and this is the 3D flatness result. So as you can see, we can see the result of the flatness from this graph. Okay, so for the next is the conclusion. As the conclusion, during my internship, I have gained knowledge on the operating of semiconductor industry and how important wearing a proper PPE in the clean room. And I also learn from all the process we need to follow the set parameter to meet the standard specification. And I also gain a mechanical knowledge on how to have a good handling to handle the machine and tools. Mostly I learn the mechanical knowledge from the lid locking tab machine conversion. And then all of the tasks and exercise given by my supervisor had been much helpful in terms of technical knowledge, practical works and data analysis. It helped me it helped me a lot. And lastly, during my internship, we have facing so much case on COVID-19, but ST provide good welfare to for the all employers so that the employers can work in healthy condition as long as we face the COVID-19 pandemic. So this is from I think that's all from me. Thank you for giving me a chance to present to you, and I hope you enjoy from hearing my presentation. Thank you.